without wasting much time, let us start with this question where you people have doubts, and this question is from the chapter Binomial Theorems. So this question involves the theorem, the usage of it. Now let's start the question. As we know that the question says, show that the term independent of x in the expansion of x plus 1 by x whole to the power 2n is given as the follows. So what we are going to do is, first we start expanding x plus 1 by x to the power 2n. But first we have to let the independent term. So the independent term which we let is going to be t r plus 1. So tr plus 1 can be the independent term which we let. And as you see, this is the expansion of the following term. And as we know, expansion follows the way that as the number is r plus 1, our expansion is going to be minus 1. ठीक है, तो 2n c r x 2n minus r 1 by x to the power r. Then we go forward and we just solve this further. We take this x to the power r above and we get something like this. Now, as we know that it is given in the question that our term should be independent of x, so we can keep 2n minus 2r equal to 0. So we find something like this happening, that as this happened, what we can do is, now we have to find that the term which is independent of x. So we solve this term 2n cr, putting n is equals to r. So when we solve, what we get is 2n cn. And now by combination, we know that this can be solved as 2n factorial by n factorial 2n minus n factorial. Guys, this is very basic knowledge that by factorial or by combination we can solve this manner. So what we get is 2n factorial by n factorial, and 2n minus n is n factorial. Now as 2n could be written in the following way: 1 into 2 into 3 into 4, which is goes to 2n, and the following thing could be written n factorial. Now what we can do is, we see something like this: 1 into 2 into 3 till infinitely till 2n. Now as this is 2n, we can confidently say that it is something an even number. If it would have been 1, the answer would have been 2. If n was even like 2, the answer was 4. 2 into 2 4. So this is something like even. So if we make two sets out of it, a even set and a odd set, what we get is, first if I make a even set, so 2 into 4 into 8 till 2n I'm going to reach. And if I make a odd set out here, what I'm going to get is 1 into 3 into 5 till 2n minus 1. Now why 2n minus 1? Because if 2n is even, minus 1 is always going to be odd, and the last odd number, this is going to be the last odd number. And as usual, we write n into n downwards. Now what happens is that we see that if there is 2 everywhere in the odd set, in the even set, so can we write like this? And as follows. Now what I'm going to do is, I'm going to take these 2 out as commons. So there are so many 2's. So I can take 2 to the power a, 2 to the power n as the common thing. And then what we are left with behind is this. Now this was something which is already with us, and now we know 1 into 2 into 3 till n is n factorial itself. So we arrange it properly, and what we get, this removed. Now we have an answer. This. And if we match the answer, we get the same thing. So yes, we've proved the thing, and this is the answer. The video is not too long, 5 minutes. So good. If you've understood it, then it's fine. If not, you can ask the question back in the comment section below. Thank you.